Consider in our microservices project, we have multiple microservices. For example, microservice 1, microservice 2, and then microservice 3, and so on. Okay, and each microservice have a host name and port. For example, let's say microservice 1 is running on port 8080, microservice 2 is running on port 8081, and microservice 3 is running on 8083. And in order to scale our microservices project, we can run multiple instances of each microservices, right? For example, let's say if we want to scale microservice 1, then we can start another instance of microservice 1. For example, let's say the instance is running on port 8084 and another instance will run on a port 8085. Okay, and each microservice exposes the REST APIs. Alright, next here we have a client. It consumes REST APIs from multiple microservices. For example, let's say client consume the REST APIs from microservice 1, microservice 2, and microservice 3. Well, in order to consume the REST APIs from microservice 1, microservice 2, microservice 3, client have to know the URL of all the REST APIs. Well, in enterprise application, we may have hundreds and thousands of microservices, and it is not a good idea that client have to interact with all those microservices, isn't it? So basically client have to remember all the host and ports of all the microservices that it want to consume. So in order to solve this problem, we can use API gateway. Well, API gateway basically sit at the middle of client and backend microservices, and whenever client want to consume the REST APIs from multiple microservices, then client have to first send a request to the API gateway. It don't have to interact with directly to the multiple microservices. Okay, so this is awesome, right? So client don't have to remember host and ports of all the microservices that it want to consume. It just have to send a request to API gateway. That's it. API gateway take care of routing that request to appropriate microservice. Okay, so this is how the API gateway solves the problem. Okay, client don't have to tightly coupled with multiple microservices. Client just have to send a request to API gateway. API gateway, based on the rules or the URL rules, it will forward that request to appropriate microservice. So API gateway we basically use to route the request, and second is we can also use API gateway for load balancing. For example, let's say we want to scale microservice 1, then we'll start multiple instances of microservice 1, and then API gateway will take care of routing the request to particular instance. Okay, in this way API gateway also capable to handle the load balancing. Next, security. Consider we are not using API gateway, then what will happen? Each and every microservice have to implement its own security, and client have to authenticate with each and every microservice, isn't it? So this is basically a tedious process. Alright, so client have to authenticate with each and every microservice it want to communicate. So this is a tedious process, isn't it? So API gateway basically address this problem. We just have to implement centralized security in a API gateway. Client just have to authenticate with API gateway. That's it. Client don't have to authenticate with each and every microservice it want to communicate. And API gateway will take care of authenticating the client request. And if there is any issue, then API gateway will send a response back to the client. Alright, so API gateway will address this security cross-cutting concern as well. Alright, great. I will see you in the next lecture.